Composite function domains. Our objective here, determine the domains of composite functions. And we saw how to create composite functions in a previous video. Now we're going to determine how do we come up with their domains. A little bit slightly unique. So we know what a composite function is. It's a function made up of other functions, and we're working with two, where the output of one is the input of the other. And we know that the domain is the set of all input values, x values, that return a real number as an output value, a y value. Okay, and we want to be careful. As usual, we want to be careful of fractions and even radicals. Okay, so the following numbers are excluded from the domain. Remember these two things. Any x value that is not in the domain of the first function or the inside function. If it's not in the domain of the inside function, it can't even get started. It can't even go through the first function. Okay, there's no output to work with. And then second, any x value that is not in the domain of the composite function. When you're all done, if there's an x value that's not in that domain, it's not in the domain of the composite function of the composite function. Okay, so those are the ones that we want to exclude. Is it not in the domain of the first function? It's excluded. Is it not in the domain of the composite function? It's excluded, and then we'll combine those two things as necessary. So, do an example, and we'll show you that. Okay, we're given f of x is 2 divided by x minus 1. Uh-oh, I'm thinking fraction, problem here. And g of x is 3 over x. Again, I'm thinking fraction. You got to be aware of what's going on. Find f of g of x. And find the domain of f of g. Okay, let's first find f of g of x. We know that f of g of x is equal to f of g of x. And this is how we see the inside function. Of course, it's the one closest to, in this case, I just like saying it this way. It's much more popular, actually. Okay, so what is our g of x function? Our g of x function says 3 divided by x. That's fine. This x goes in, 3 divided by x comes out. This is the input into the f function. Okay, so we put in x, we got out 3 over x. We're now going to put 3 over x into the f function. And we know the input of the f function is going to be written in the denominator down here. Okay, we're going to do that to it. Okay, so f of g of x is equal to 2 divided by, well, there's a 3 over x minus 1, and we have just created a compound fraction that we need to simplify. Okay, so let's simplify this by multiplying numerator and denominator by x. We can multiply anything by 1. This is a 1, and we'll have the same. We haven't changed what we began with. If we multiply it by x, this becomes 2x, numerator times numerator. Denominator times denominator is going to be 3 minus x. Okay, so here is our composite function, f of g of x. Okay, so letter A, find f of g of x. We did that. We did the g function first. Out came 3 over x. We put 3 over x into the f function, and out came 2x divided by 3 minus x. So now what is the domain? Okay, so domain. Okay, well, we first need to look at the domain of the inside, the first function, the inside first function. So for g of x, which equals 3 over x, the domain excludes 0. Can't divide by 0. Okay, that's pretty simple. Now, for f of g of x, which was 2x divided by 3 minus x, that's also a fraction. Our denominator cannot be 0. Our domain excludes 3 because 3 minus 3 is 0. Okay, so we had to come up with, do we have anything that's excluded in the first function? And the answer is yes. In the first function, we can't put 0 in there. Do we have anything that is excluded from the composite function? And the answer is yes. I have a denominator of 3 minus x. X cannot be 3. So both the 0 and 3 are excluded. Okay, so the domain of the composite function, okay, is equal to, well, we got to exclude 0 and 3, so negative infinity to 0, union 0 to 3, union 3 to positive infinity. This is excluding the 0 and excluding the 3 right there. So what you need to be aware of here, again, back to our 2 bullets up here, any x that is not in the domain of the first function is out. Any x that is not in the domain of the composite function is out. The result of those 2 is the domain of the composite function, I guess, in its entirety, let's say. Okay?